It's kind of fun to think about your brain as a computer, right? It's got this super complex operating system running in the background, handling everything from your breathing to your most brilliant ideas. So today, we're going to pop the hood and actually look at the user guide for one of its most important programs, memory.
I mean, come on, we've all been there. You can belt out every single word to a song you haven't heard in 20 years, but you have no clue where you put your keys 20 minutes ago. Here's the thing, though. That's not a glitch. It's actually a feature of how your brain's operating system is designed.
So, let's get into it. We're going to take a tour of this amazing, and yeah, sometimes totally baffling system. By the end, you'll get why those song lyrics stick around forever, while the location of your keys just vanishes.
Okay, first up, let's follow a single piece of information on its journey. Imagine it's a new name you just heard, or a cool fact, or even just an image. We're going to track how it goes from the outside world into the massive hard drive inside your head.
So everything we see, hear, and feel makes its first stop right here in what's called sensory memory. It's like a super fast, high-def snapshot of the world, but it's incredibly brief. We're talking less than a second, and then poof, it's gone. Think of it as your brain's reception area. Information checks in, but it doesn't stick around.
Now, if you actually pay attention to something in that fleeting snapshot, it gets a promotion. It moves up to your short-term memory. The best way to think of this is like the RAM on your computer. It holds whatever you're actively thinking about right now. But there's a catch. It has a really strict time limit, usually less than 30 seconds. This is why when you put your keys down while you're distracted, that memory might not even make it this far.
And it's not just temporary, it's also kind of small. See, most of us can only hold about 7 things, give or take 2, in our short-term memory at any given moment. This magic number is no accident. It's the very reason phone numbers are the length they are. It's just the sweet spot for our brain's RAM.
So if our mental RAM is so limited, how does anything ever stick? Well, for that, we need the brain's hard drive, long-term memory. When you actively work with information, by repeating it, thinking about what it means, or connecting it to stuff you already know, you're basically telling your brain, hey, this file is important, save it permanently. And that is exactly what happens with a song you love and what doesn't happen when you toss your keys on the counter.
So really, it all boils down to this simple 3-step process. Everything starts as sensory input, but the real gatekeepers here are attention and rehearsal. If you don't pay attention, the information just disappears. And if you don't rehearse it or process it, it gets kicked right out of your short-term memory. These 2 steps are the secret to saving a memory for good.
And this table just lays it all out so clearly. I mean, look at the huge differences. Check out the duration. Sensory memory is a flash in the pan, gone in under 2 seconds. Short-term gives you maybe 30 seconds. But long-term, that can last your entire lifetime. And the capacity? You go from that tiny 7-item limit in your mental RAM to a practically unlimited hard drive. It just shows how critical that journey from one stage to the next really is.
Of course, sometimes we can't seem to find a file, even when we know it's on the hard drive. But here's the thing. Forgetting isn't always a bug. Let's take a look at why it happens. It's actually a predictable and sometimes even useful feature of our memory.
We usually think that memories just fade over time, like an old photo. And yeah, that can happen. But a much bigger culprit for forgetting is something called interference. It's basically when different memories get in each other's way, like crossed signals. That's why you can't remember where you put your keys. Your brain was already crowded with the 10 other things on your to-do list.
And this interference comes in 2 main flavors. First, you've got retroactive interference. That's when new stuff messes with your ability to remember old stuff. So you start learning Spanish, and suddenly you can't remember those French words you learned last year. Then there's proactive interference, which is the other way around. Old learning gets in the way of the new. That's you in a new automatic car, stomping on the floor where the clutch used to be because your old driving habits are just so deeply wired in.
Okay, so we've diagnosed some of the system's quirks. The big question is, how do we upgrade it? Let's dive into how we can actually use this knowledge to make our memory work for us, not against us.
This right here is a fantastic overview of some really powerful strategies. And it's a great reminder that it's not really about having a good or bad memory. It's about using the right techniques to save and retrieve information the right way.
And here are some of the best ones you can start using today. Deep processing, that's thinking about the meaning of something, is exactly why song lyrics stick. They're tied to emotions and stories. And distributed practice, studying in short bursts over time instead of cramming, is why a song you hear a few times a year for a decade gets burned into your brain.
We forget our keys because we do the exact opposite. Zero processing, zero practice.
This is such a perfect example of using shorthand codes, or what experts call mnemonics. I mean, trying to remember violet, indigo, blue, green, yellow, orange, and red is a pain. But just remembering one simple, catchy word, VibJor, anybody can do that. It's a brilliant little hack that gives our brain a powerful shortcut.
So we've figured out how to store files and how to find them again. But what's the whole point of having this massive hard drive in the first place? Well, it's for way more than just storage. It's for running our most advanced, most creative programs.
And this is so important to get. A great memory isn't just about trivia. Every new idea, every single innovative solution is built by combining old pieces of information in brand new ways. Your long-term memory isn't some dusty museum. It's the workshop where your mind builds the future.
And that creativity, it's not just some random flash of lightning. Psychologists have actually mapped it out. It starts with preparation. That's you loading your brain up with all the facts and materials. But then comes this really crucial step, incubation. That's where you actually step away and let your unconscious mind just chew on the problem for a while.
And that all-important incubation time is what leads to stage 3, illumination. This is it. This is the aha moment. That feeling when the solution just pops into your head, seemingly out of nowhere. It feels like magic, but it's really just the system working perfectly in the background.
And that's the final piece of the puzzle. That aha moment happens when your brain makes a new connection between ideas that were already sitting there in your long-term memory. A strong, well-organized memory is literally the launchpad for all creative problem solving.
So there you have it, a quick tour of your brain's operating system. We've seen how it saves files, why it sometimes loses them, and most importantly, how it uses all that stored data to create something entirely new. So the real question is, now that you know a little more about how your mind works, what are you going to do with it?